and welcome to our video series on embedded programming. For my classes, this is the program that is taken by predominantly my seniors and some of my highly skilled underclassmen who have typically completed at least one of the pathways or on their way to completing one of our computer science pathways. We deal with robotics and embedded systems in this class, and it's really a lot of fun to play with all these different types of devices in our lab. And this video series is going to help you come up with some of the base terminology and some of the fundamental concepts that we're going to use in the lab, and hopefully it'll make some of these clear. And these will be points of further research for all of my students. So if you've never dealt with embedded systems or robotics, these, I think we're going to do about 8 videos, are going to be very useful for you. And to kick it off, we're going to start by talking about what an embedded system really is. What is embedded programming? And we're going to talk specifically about embedded systems. Now, when we talk about embedded systems, we're obviously talking about something that has a computer processor, right? It has to have some sort of a brain that can execute instruction sets. It's got to have memory. It has to be able to store its state, whether that's what the robot is currently doing, what it has done, what it has sensed, or where the device is positionally. What is the temperature of the sensor? There's all kinds of things that the computer needs to store, and that has to do with its state, so it's going to need memory. Also, it's going to need input and output peripherals, specifically for anything robotics or mechanical. A lot of times we're going to take control signals and move mechanical or hydraulic arms. There's really all kinds of things that we do with embedded systems, so we're going to need input and output devices. And when you think about input devices, don't just think about mice and keyboards. It could be a temperature sensor that then suddenly turns on a cooling pump or turns it off. So there's all kinds of things that can have input to the system when we're dealing with embedded systems. Okay. All of these things, when we refer to a specific embedded system, we're referring to something that has a very dedicated function. And the reason we say that is a lot of the components that make up the embedded system are going to be highly tuned, meaning it may not have the entire Linux operating system on it. It may not be big enough to do that. It may only have enough of a given operating system or a library or a language to do what it needs to do. We're going to take all of the unnecessary stuff off of that system so that we can use it in a very small modular way as part of some other system. So they're very, very tuned, and it's very, very specified. And any given embedded system is part of something larger. Okay? You'll have an embedded system that will run the robots that assemble cars. Okay? And there may be several embedded systems that have dedicated functions in that larger system. Okay? All right, so we're going to talk about 2 categories of devices, and what you really need to understand is, like everything in computer science, it's all changing and it's all merging. Microprocessors and microcontrollers, they're kind of getting a lot closer to each other as systems get smaller. But I want to make sure that you understand the theoretical difference between the two. So we have microprocessors, which is kind of what you think about when you think about a computer. But then we get to these things called microcontrollers. So let's talk about them. Microprocessors have a CPU which uses external RAM and external peripherals, chips that are external to the CPU. Well, if you think about your laptop, that's exactly what we're talking about, or your desktop, or even a tablet. You've got a processor and you've got RAM that's not on the chip, and you have input, output, you've got expansion ports, USB ports. That's a typical microprocessor. A microcontroller, on the other hand, can have internal RAM and internal peripheral devices. So it can have peripheral attachments and controllers that are part of itself. And the RAM and its ability to store its state is actually internal. Okay, so that's kind of the difference between the two. But as we get to some of these devices, you're going to see that as microprocessors get smaller, the use case for having microprocessors and not needing to build a microcontroller those lines get really, really blurry. Okay? So, again, I want to say embedded systems have a very specific purpose because I don't need to put an entire Windows 10 computer in something that's only going to move an arm in two directions. Okay? I can take a lot of that away and only have the code or the instruction sets that it needs to do what it needs to do. Okay? And by the way, that also makes it very, very much cheaper. It's less expensive to build these things and to mass produce them. All right, so let's talk about some of the devices that you're going to see out there and that some of which we're going to use. So we have the Raspberry Pis and the Raspberry Pi Zeros. Now these things, I can't get enough of them. They are just really, really powerful. I bought my first Raspberry Pi 4 this past summer during the COVID-19 pandemic because they now come with 8 gigs of RAM and support for 2 video cards. I mean, these things are full Linux computers the size of a credit card. The Pi Zeros, a little less powerful, but they're very, very small and they're perfect for building some sort of an embedded system. So Raspberry Pis are extremely powerful. They're getting more and more powerful, and it's just a phenomenal device. And if we look at some of the others out there, there's a thing that's been around for years called a BASIC stamp. Now, a lot of you may not have even heard of BASIC. Us old guys know it because it stands for the Beginner's All-Purpose Symbolic Instructional Code. And it's an interpreted language. It's a very simple language, and it can be used for very simple programs. And these chipsets have a basic interpreter on them and enough RAM to store small programs, enough memory. And you can wire them up on a little breadboard, put them on a circuit, and you can do very simple types of programming with input-output using them. And they're very, very popular. If you're interested in looking at that to see what it's like, just Google it and you will find all kinds of projects that you can do with a BASIC stamp. It's not nearly as powerful as the new Pis. In fact, the Raspberry Pis are kind of making some of these things more and more obsolete. So we also have these little tiny guys called Espruino, I think I'm saying that right, and they hold really small programs for little devices and have some I/O functionality, but those are really tiny. And then we have one that is actually no longer sold. It's called the Light Blue Bean, and it's a similar format where it had analog SPI, I2C, and a digital input-output system, and you could do small projects on that thing as well. Unfortunately, it's been kind of overcome by events and better systems, so it's no longer for sale from what I could see. Then we have this Little Bits Arduino, and these are tiny little components that you can magnetically snap together, and you can't do it wrong because the magnets of similar polarity will repel each other, so that you have to connect them in the right order. And that's kind of an educational toolkit to show kids simple projects like turning on an LED light, playing with sound and switches. But it's really cool for younger kids and even older kids that just want to play around with that have never done anything with circuitry. And those are still, you can still find them out there. Very simple kits. It's nothing on the order of a Raspberry Pi, but they're worth taking a look at if that kind of thing can help you or any of your kids. All right, so in the next video, we're going to start to look at some of the networking protocols. Some we use every day and don't even think about, and others are kind of specific to embedded systems. So we'll take care of that on the other side.